Excellent work. Keep it up. Now let's move on to example 3. Here's the tricky one. Let's get a little abstract on you. I'm going to take away the numbers, just put in a variable x, and ask you, what is the sine of an angle who has the arc cosine of x? That sounds pretty tricky at first, but let's break it down in its little parts. The first thing I notice is that you want me to find the arc cosine of x. Who has what angle has a cosine of x? Well, draw a picture. Here's my triangle. Here's my angle. Notice I'm just kind of arbitrarily drawing it because trig ratios are going to be the same no matter where you are. And your cosine means that your adjacent over your hypotenuse is x. So that I know is guaranteed. Now we do have one problem. When I took arc cosine, remember the trick is we're in either quadrants 1 or 2. So how do we know which one we're in? And you're right, that's a little stressful. However, if I look at the second part of the problem where we're going to be taking the sine, in quadrant 1, sine is positive. In quadrant 2, sine is positive. So we don't have to worry. We're just going to do it in quadrant 1 where everybody's positive. But that was only because we were taking the sine and we were able to rule out any negative numbers. All right. Now, a little Pythagorean theorem tells me that a squared plus b squared equals c squared. So, looks like 1 squared minus x squared square rooted. That's got to be our missing side. Ugh. But we're done, right? If the cosine of some angle is x, then I can tell you the sine of that exact same angle has to be opposite over hypotenuse, which means 1 minus x squared over 1, or what most people would just call the square root of 1 minus x squared. Done. By the way, don't reduce that radical. It's tempting. You know the square root of 1, you know the square root of x squared, but that negative is holding them together. You know, if you want to check, factor it, you know it's a difference of squares. 1 minus x, 1 plus x. Those aren't the same, so it's not squared, so I can't cancel it. So can't do anything, and we're good. And there is the sine of the arc cosine of x. All right, let's try another one, just to make sure. Let's try the cotangent of the arc sine of 2x. Throw a 2 in there, maybe I'll scare you a little bit or something. I doubt it now. First thing I'm going to look at is who has an arc sine of 2x. Notice that we have to worry about being in quadrants 1 and 4. Good thing they're asking cotangent. They are also in quadrants 1 and 4. So life's feeling pretty good right now. I will draw a triangle that has a sine of 2x. So if you have a sine of 2x, that means your opposite is 2x, your hypotenuse is 1. Must be talking about that angle. Again, good friend Pythagorean theorem says that 1 squared minus 2x squared square rooted will get us the other side. So I think most of us would like to call that 1 minus 4x squared. And there's our triangle. Notice the x will be getting squared, so life is good. So now I can finally answer what the heck is cotangent. Tangent is opposite over adjacent, so cotangent would have to be adjacent 1 minus 4x squared over the opposite, 2x. Again, don't try to reduce because that square root, it's a difference of squares, 1 plus 2x and 1 minus 2x. Not going to help me in any way, so I am finished. Give one a try, and we'll see you later. Stay happy.